Hello everyone, welcome back. I am Deepak Unyal and we are discussing compilation phases. So in compilation phases, in first thing we have discussed was creation of source file. Second thing we have discussed was pre-processing. Third point we are going to discuss here is compilation phase. Although full process is called compilation phase, but there is one step which is specifically will be compiling the program. Then there will be assembly phase, and fifth thing linking, and there comes loading and execution. So we will be discussing all these steps one by one, as we have seen two steps already. So what we are going to do now, we are going to compile a file, or we are going to get a file which compiler translates from hello.ii in C++, or I can say hello.i in C to hello.s. and what this hello.s contains, there are some low level machine instruction. Low level machine language instruction, I would say. This file contains assembly language, instruction. These low level machine language instructions are called assembly language instructions, or we know that these are also called mnemonics. So what I can do, I can try to compile the program and then see hello.s what it contains. So we can see here that this is assembly code, and all these are mnemonics written inside this file, and this will be depending on the architecture of a particular machine. We need some assembler which can translate this assembly code into some another form. And what is that another form? Here in this case, this another form is hello.o, or we also call object file. This is also low level machine language instruction, and this assembly code is hello.s. So one important thing here is that these assembly language instructions are stored in text form, as we have already seen, but this object file is in binary. That will be looking in a while. One important thing I would like to discuss, that these this assembler packages the code or packages the instruction in a form called relocatable object code or relocatable object program. What this relocatable object program means, we will not be discussing this at this point, but all this is stored in hello.o. I will try to see we don't need to compile it every time, but I can go to hello.object file and see what it contains. You can see here that whole file is in binary format. And there is one more thing here. This is called ELF, or this ELF is called executable and linkable format. I will try to write this. We see a word in file which is ELF, and this ELF means that it is executable and linkable format. What does this means? That this file can be executable or can be linked to another files. Till this step, we could have some symbols, or we could have some functions in a file that are still not resolved. If you talk about C, let us take an example of C. Example C. There are some function like printf or scanf. So these functions are still not resolved and are packaged in the form of object files. So printf will be available in printf.o form, and scanf will be available in form of scanf.o. So all these object files have some format, that is ELF format, which is executable and linkable format. So in the next phase, that is called linking, all these objects file will be linked together to produce a single file. This single file could be, suppose I am writing a source file compilation.cpp. So the file we could get, it could be compilation.exe or compilation, or it could be a.out. So what linker actually does? It takes a collection of object modules and produce a load module that is used in next step of the compilation phase and used by loader. And what it does, just go back and see what is inside compilation file. You can see here that this is also a binary code, and the format is executable and linkable format. One thing I have shown you in previous step, that I have seen object file of hello, but I can see object file of compilation also, and that will be similar to hello.o, and there is no difference, although its length is more than that, but the basic is same, that file is in binary format and its format is ELF. So both the files, assembly phase, that we get from assembly phase and that we get from linker phase, are both binary files and have a executable and linkable format. Even in this step, after the linking, we can get some symbols, or there might be some references in our file that are still not resolved. Some references might not be resolved at this point. So loading comes into the picture then, and those references can be resolved at the either loading time or at the execution time. So what is loading? before a program can be executed, it must first be placed in a memory, and this is done by loader. Program should be placed in memory or main memory, that we also call RAM, before its execution. So this thing is necessary to load the program in memory. And what it does, it takes executable image from hard disk and transfers it to memory. So there might be some additional components from the shared libraries that also need to be loaded into the memory. If there are some modules that are not loaded at this point, that can be loaded at execution time. So let us see the file here. As soon as I try to run this program in this way, I write / and then compilation. This command will load the program in main memory and will start executing it line by line, right? So this way a program can be executed. So I will write one line only. Under the control of CPU, or I can say computer under the control of CPU executes the program one instruction at a time. But there are some modern architecture that can execute several instructions in parallel as well. So I think this is enough for the this lecture. If you have any doubt regarding compilation phases, please either write in comments or you can mail me. I will try to revert back. Thank you so much.